This is mathheals.com if you want to go there to get more math videos. They're just links to YouTube, basically. Let's take a look at the law of sines. And first let's talk about the formulas. Law of sines. This says sine of angle A over side A is equal to sine of angle B over side B equals sine of angle C over side C. Or you can use these formulas. Side A over angle or sine of angle A is equal to side B over sine of angle B equals side C over sine of angle C. Now the capital A, B, and C represent angles. Little a, little b, and little c always represent the sides. The triangle we're talking about, we're no longer dealing with a right triangle, but let's say that side's, or that angle's A, that angle's B, and that angle's C. The side opposite of them would be the corresponding one. So this is angle C, this is side C. This is angle A, this is side A. This is angle B, this is side B. And do you use this top formula or bottom formula? That kind of depends on what you're solving for. If I'm solving for one of the sides, I want to use the bottom formulas. If I'm solving for one of the angles, I want to use the top formulas. Now, you never use all three fractions at any given time. You would only use like the first two here, or the first one and the third one, or second one and third one, for example. You have to look at what's given. You're looking for two knowns, basically. Let's actually solve a triangle. We're given B is equal to 35 degrees. A is 45 degrees. And side C is 7. Well, let's look at angle C. All the angles add up to 180 degrees, so that'll be the easiest one to start with. C is going to equal to 180 degrees minus A minus B. So we got 180 minus A, which is 45, minus B, which is 35. What was that, 80? So 100 degrees. Okay, now this is an exact value here, so we could use that. Any approximations we try to steer away from using. Sometimes we're forced to use them, but we try to steer away from them. Okay, so now I know you're looking for two items. Either I know side A and angle A, side B and angle B, or side C and angle C. Well, I know this one, and I now know this one. I know both C's, don't I? So that's the pair that I know. So we're going to find side A. Now we're solving for a side, so I'm going to use these bottom formulas. So I'll put A over sine A equals, and to decide which one to use the B's or to use the C's, well, we said we know the pair of C's, don't we? So we're going to use the C's. You go with the ones you know. Okay, so we got A over sine A, which is 45 degrees, equals C, or side C, which is 7 over sine C, and C was 100 degrees. Now we're going to multiply both sides by sine 45 degrees. So we got A is equal to 7 sine 45 degrees over sine of 100 degrees. So A is going to equal to, make sure your calculator's in degrees. You press mode, and then you down arrow, and make sure degrees is chose. If it isn't, then you down arrow, put your right arrow, put your cursor on it, and press enter one time. And then do second mode, exit out. Okay, so we got 7 sine of 45 degrees, closing parentheses, divided by sine of 100 degrees. Now I'll take it to 2 decimal places, 5.03. Well, now we know both A's. I know this A and I know this A. But we do not want to use the A's because this is an approximation. So we want to go back to the C's when we're working with this. Always go with the one that is an approximation if you can. Okay, so let's find B. So I'll put B over sine B. And we've already indicated we have to go with the C's. So we'll do C over sine C. So I got B over sine B, which B was 35 degrees, equals 7 over sine of 100 degrees. Now we'll multiply both sides by sine 35 degrees. So we got 7 sine 35 degrees over sine of 100 degrees. And let's go put that in, see what we get. 7 sine of 35, close parentheses, divided by sine of, I think it was 100, wasn't it? Yeah. 100 degrees. And 2 decimal places, we get 4.08. Now solving a triangle basically means find all the missing sides and angles, which we just did. Now notice 100 degrees is our largest angle, C is 7, it's the largest side. Our smallest angle is 35 for the B, and little b is 4.08, which is our smallest side. That's the way it should work. That's kind of a quick check you can do to make sure that at least that part's correct. That sometimes points out math errors. Let's look at our second example. Okay, so we got B is equal to 20 degrees. Little b is 8. Or angle C. Boy, my eyes aren't very good. 110 degrees. Now the two that we know, we got a pair of B's, don't we? So those are the two we're going to use because we're looking for a pair. Either pair of A's, pair of B's, pair of C's. And so we're already given those. Well, the easy one, angle A. A is going to equal to 180 degrees minus the other two angles, minus B minus C. So we got 180 minus 20 degrees minus 110 degrees. Was that 50? 160, 50 degrees. Okay, now we want to find, let's just go ahead and find side A. So again, I have to go with A over sine A. That's no choice there. And we want to go with the pair we know. We know the B's. So I want B over sine B. So I got A over sine of 50 degrees equals B, which was 8 over sine B, angle B, which is 20 degrees. Now multiply both sides by sine of 50. Let me scroll down a little bit here. So we get A is equal to 8 sine of 50 degrees over sine of 20 degrees. So we got 8 sine 50, close parentheses, divided by sine of 20. Enter. And 2 decimal places, we get 17.92. Like that. Now we know our A's, but this is an approximation. So again, I have to go back to my B's. So over here I want to find side C. So I'll have C over sine C equals B over sine B. Okay, so we don't know side C. Angle C was 110 degrees. B is still 8, and angle B is 20 degrees. Now I'm going to multiply both sides by sine 110 degrees. So we got C is equal to 8 sine 110 degrees over sine 20 degrees. So C is going to equal to 8 sine of 110, close parentheses, divided by sine 20. And enter. And we get 21.98. And see, our largest angle is C, and that's our largest side, so that works. Smallest angle is B, and our side B is the smallest one, so that works. Let's look at one more solvent triangle. So we got B is equal to 30 degrees, A is 4, and C is 60. Unfortunately, we don't have a pair yet. We don't got a pair of A's, pair of B's, or pair of C's. But let's go ahead and find our angle A, because it's the easiest one since we know both angles here. So A is going to equal to 180 minus angle B minus angle C. So we got 180 minus 30 degrees minus 60 degrees. And that's 90, so that gives us A is equal to 90 degrees. Now this tells you something about this. When this is 90 degrees, that's a right triangle. This would be A, or 90 degrees. Doesn't matter where you put B and C. And then side A is over here, which is our hypotenuse, which is 4. And we can do this different ways. I'm going to go back to the right triangle to show that. But you could use the law of sines. It actually works. So let's find B. Okay, so this is angle B, this is side B, this is angle C, this is side C. And I'll pick one angle to work with. Doesn't matter which one. I'll pick B, I guess. Okay, so in reference to angle B, this little b here is opposite side. And I know, what do I know? I know the hypotenuse. So opposite over hypotenuse is sine. So we can say sine B is opposite over hypotenuse. And B is 30 degrees equals opposite, which is little b over hypotenuse, which was 4. Because this is our hypotenuse. Multiply both sides by 4. And we've got 4 sine 30 degrees is equal to a little b. 4 sine of 30 degrees is 2. Now we know A, we know little b. We can use Pythagorean theorem to get side C. So we got a squared plus b squared is equal to c squared. So we got 4 squared plus b is 2, so 2 squared is equal to c squared. So that gives us 16 plus 4 is equal to c squared. 20 is equal to c squared. Drop our squared, and normally we put a plus or minus square root on the other side, but since we're talking about distance, it's just square root. So we got c is equal to square root of 20. Now 20 is 2 times 2 times 5. We're looking for a pair of somethings. Here's a pair of 2's, so that's going to come out as a single 2. So c is equal to 2 square root of 5. And I'll go ahead and put in my calculator, get a decimal. So I'll do 2, and then second, x squared, 5, enter. And we get 4.47. And we just finished solving that triangle. So let me save that. And what is this? Law of sines. So trig, law of sines, page 01, PDF. Now this next problem, problems are kind of broke down. They want you to analyze it first and see how many answers you're going to have. You could have no triangles. For example, If I had one side that was this long, and you had one side that was this long, and one side that was this long, there's no way you can connect those together to even form a triangle. So that's the no triangle case. You can have a right triangle, which that means your sides, of course, come up like this, 90 degrees. You can have two triangles. Well, let's suppose that I know this distance right here. Let's say it's, I don't know, 4. And I know this angle here. Say it's 20 degrees. Or actually, that's probably about 40 degrees, isn't it? But oh well, you get the idea. Let me put 40 there. Now, let's say I know this side over here. Let's say it's 5. So that could be one triangle, excluding this part over here. I could also, if this is 4, well, that's a bad example. Let's say that's 3. Okay, so let's say that's 3. So I could put it that way, or I could put it back this way, so that'd be 3. So there's two different ways you could have that. You could rotate it out like this, or you could swing it in like this. And then we'd have our same triangle here. So there's two triangles. And then there's just the one triangle case, where the way the sides line up, you just have one choice. Now I kind of came up with some steps to help with the two triangle problems, but I don't really like them very well. They're not refined yet. This is like version 1. The example is the best way to see it. Okay, it says solve the first triangle with the given information just like normal. To find the other triangle, the new angle opposite to side P will be given by 180 minus capital P. Then use this information to solve the other triangle. That'll make sense once we look at this. Okay, so let's look at our problem. And we got two sides and an angle are given. Determine whether the given information results in one triangle, two triangles, or no triangles at all. Solve any triangular result. So we got A is equal to 40 degrees, little a is 6, and little b is 9. Yeah, let's kind of draw this picture. Kind of get an idea for it. And I'm not sure if I have enough room for this problem, but yeah, probably enough. Okay. So I got an angle A here. That's my angle A. Now side A, that's the one opposite of this angle. So that right here is side A. And then the other one has to be put up here. So that's just your setup on that. If you're given an angle and the side opposite of it, you do that, and then the other side that's given, you put right there. Now to match this up against our diagram here, you see theta is the angle, which is in our case A. So theta is equal to A, which is equal to 40 degrees. This side here is little p. So little p is going to equal to B, which is equal to 9. And then this side over here, our opposite, is in this case A. So opposite is equal to A, which is equal to 6. Well, this says right here says we have to find H is equal to P sine theta. So H is equal to P sine theta. Well, P is 9 and theta is 40 degrees. So let's see what that gives us for H. And you know, I don't think I changed the numbers in this next problem. So well. So 9 sine 40 degrees. So 9 sine 40 degrees, enter, and I get 5.79, 2 decimal places. So I come over here, and you see which one this matches. Opposite is less than h. Opposite was 6, and h is 5.79. That's not true. If that was true, that'd be a no triangle case. Opposite is equal to h. Well, opposite is 6, h is 5.79. They're not equal, are they? Let me go down the one triangle. Opposite is greater than p. Opposite is 6, p is 9, 6 is not greater than 9. So I come over to this case. Opposite is greater than h. Opposite is 6, and h is 5.79, so that's true. Opposite is greater than h. And opposite is less than p. Opposite is 6, p is 9, so opposite is less than p. So that works. That means that we have two triangles. And let's look at our first triangle. So triangle 1. We do it just like normal. So A is 40 degrees, little a is 6, and little b is 9. Okay, now we need a pair of somethings. Here's an A and here's an A. Well, that's a perfect pair to use. So we're going to use that to help us solve for the other ones. Now I know B, so logically we want to start with finding an angle B. So I'm fine with that. So sine B over side B, little b, is equal to sine A over little a. Now again, I go with the A's because I know both of those. So we got sine B over little b, which was 9, equals sine A, so sine of 40 degrees over little a, which was 6. Now I want to multiply both sides by 9. So I got sine B is equal to 9 sine 40 degrees over 6. We're solving for B, so I'm going to take inverse sine of both sides. Sine 40 degrees over 6. The inverse sine and sine cancel each other out, and you got angle B is equal to, and let's go plug this in our calculator. So we got inverse sine, so do second sine, and then 9 times sine 40, 9 sine 40, close parentheses on that, divided by, and there's a 6 downstairs, close parentheses and an enter. And we get 74.62 degrees. Now this is an approximation. Unfortunately, in this case, we do have to use an approximation, but this has many decimal places here, and there's actually even more than you can see on here, so it's not a bad approximation. We're going to store this off, though. You see the store button right here? We're going to press the store, and we want to store it in B. So I'm going to do alpha and then apps to put B, and then push enter. Now this is stored in the memory location B, so we can refer to it directly. Well, now we know that. Then probably the next logical one to find, if we know angle A, we know angle B, let's find angle C. So we'll find angle C. Well, C is going to equal to 180 degrees minus A minus B. So I got 180 minus A, which was 40. Minus B, which was 74.62 degrees. So I'm going to go over my calculator, and I'm going to do 180 minus 40. 40 is an exact value. Minus, and we have B stored, so I'm going to do alpha apps to get B, and then push enter. and I'll take it 2 decimal places, 65.38. Now this is an approximation, and we may have to use it. There's no, maybe not any choice there, but I'm going to store that off so that I got a lot of decimal places. So I'll press my store button, and I'm going to put it in C. So I'm going to do alpha, program, and then enter. Now that's stored off in C. Okay, so what am I missing now? Okay, I got all 3 angles. I know side A, side B, so I need side C. Okay, so we're going to use C over sine C. And we want to go back to the 2 we know. We said we know the A's, so we want to go to those. So I got A over sine A. So C we don't know. This is 65.38 and a lot of decimal places. I'll just go ahead and put 2 of them here though. Is equal to A, and A was 6 over sine A, and sine A was 40. So now we're going to multiply both sides by sine 65.38. So side C is equal to 6 times sine 65.38 degrees over sine 40 degrees. So C is going to equal to 6 sine 65.38 close parentheses. What in the world did I just do there? 0.38 divided by sine 40. And assuming I typed it in correctly, which is always kind of iffy, we get 8.49. And that would be side C. And that would be our first triangle. So let's come up here. And we're going to now work on triangle 2. Now, does not change. We still know this information. That doesn't change. A is equal to 40 degrees. Little a is 6. Little b is 9. We're now going to find the other b. Well, the other b is given by this formula. Other b is going to equal to 180 minus the first b. So I'm going to drop the other part, and we're just working with the second triangle. So we're finding b is equal to 180 minus our first b. Well, over here, what did we say b was? 74.62. So 74.62 degrees. Well, this is an approximation, so keep that in mind. I don't want to go with that. We'll talk later about why is it 180 degrees minus that, but I got that in my calculator, don't I? I stored that in B. Remember up here when I stored it in B? So if I do 180 minus B, which was not second, alpha apps to get B, and then push enter, we get our other B is 105.38. And I'll take it 2 decimal places. Now this is an approximation right here. And that's fine for rounding it and leaving it there, but we don't want to use that in other calculations unless we take it to a lot of decimal places. Well, in our calculator, this is already in a lot of decimal places. So what we're going to do is we're going to store this back into B. So I'll press store, and then I'll do alpha apps for B and push enter. So 105.3814317 is stored in B now. Okay, well, our C is the one we're going to find now. This is angle C. So we're going to have C is equal to 180 minus A minus B. Keep forgetting to put my degrees on those, but you know what I mean. 180 minus A was 40 degrees, and B was 105.38 degrees. Now again, I got that stored in the calculator, so I'm not going to type in an approximation, 105.38. So I'll do 180 minus 40 minus, and this is B. So I'm going to do my alpha apps for B and push enter. And I want to round this 2 decimal places, so I got 34.62. Now this is an approximation, and we'll have to use it in a calculation, but I don't want to use it rounded like that. So I'm going to store this off in C. So I'm going to press my store button again, and I'm going to do alpha and then program to get C, and then push enter. Now it's still an approximation, but it's out there probably, because it's more than just the decimal places you see here. I don't know how many places TI3, TI4 takes it decimal-wise, but it's many, many out there. And now we need to find side C. So side C. So we got C over sine C. And we want to go with the 2 we know. We still know the A's, don't we? That hasn't changed. For a law of sines, those are our 2 knowns, and they're not approximations, so they're the best ones to go with. So we got A over sine A. So C over sine 34.62 is equal to A, which is 6 over sine of 40 degrees. Now multiply both sides by sine 34.62, and we got C is equal to 6 times sine 34.62 degrees over sine of 40 degrees. Let's see what that gives us. 6 sine 34.62. Close parentheses on that, divided by sine 40. And enter. And we'll take it 2 decimal places, and we've got 5.30, was it? 5.3? Yeah. And that would be our side C. And those would be our missing. It was solving a triangle, so we found our 2 triangles. So now why is it 180 degrees? Okay, well if I find, if I come up here, and I got one piece that's coming down like this, and another piece is coming down like this. If I got this angle here, let's say this is B, there's some kind of geometry, postulate, theorem, or whatever, says that this angle is going to be equal to this angle, given how they're arranged. That this side here is the same as that. So these 2 angles have to be the same. Well, then if I look at this angle on this other side, well, if this is B, then this angle here is going to be 180 degrees minus B, because this angle plus this angle gives you 180 degrees. So that's why you have to subtract it from 180 to get the other B. Let me save that. Now I'm going to have to... I need to turn that volume down. That's killing me. There. Okay. I'm going to have to play with these numbers in this last problem. I'm thinking that if if this doesn't work, I'm not going to spend a whole lot of time on this. I think you get the idea. If this is 40, and let's say side A is 2 and side B is 1. Okay, so let me draw the picture of that. Of course, here's A. The side opposite of that is going to be little a. That's the way they always go. And then b we automatically put up here. So let's compare to our formula over here. If I match up against the picture, theta is our angle. So theta is going to equal to a, which is 40 degrees. This side right here is little p, which matches our b. So little p is equal to b, which is 1. And its opposite side is going to equal to a, which is equal to 2. Well, this formula we're going to plug it into. H is equal to p sine theta. P was 1. So then we've got sine of 40 degrees. 1 times anything is just one, the anything, so we just want sine 40 degrees. And that gives us, it's pretty small, 0.64. But since I got pretty small sides here, that might, well, it does make sense. Let's come over to our table. Opposite is less than h. Opposite is 2. It's less than h. That's what I was hoping for. Opposite is a. So actually, if I change this problem, let's say a is 0.2. That would work. Okay. That's what I wanted to show. Opposite is less than h. Opposite is 0.2. That's less than h. So there's no triangle. So let me come here and put that. A. Oops. 0.2. And that should definitely work. Now let me think that through just to make sure that okay, so that's theta. B is P, which is 1. There. Okay. So then I do H is equal to P sine theta. H is equal to P sine theta. So I plug in P, which is 1, sine 40 degrees. And I did sine 40, which gives me 0.64. And then H, so down to here. H is 0.64. Opposite is less than H. Opposite is less than H. Okay, that works. So that's what I was trying to show, is the no triangle case. It didn't work very well in class because the numbers I'd made up, I guess I never tested. And but now those work, so I'll go with those. And we're actually done with that section then. So let me stop the recorders. And this is the law of sines, so F10.